In a world where I am undetectable and no one can see me.
But our robot wasn't always this sophisticated. He started as just an Arduino, the brain of our robot.
We coded it with the ability to take inputs from different sensors and send outputs to the different outputs, the motors and the servos. We coded the robot using an Arduino R3 Uno. The different sensors on board the robot are 3 infrared sensors, 1 in the back and 2 in the front, and 1 ultrasonic sensor to allow it to detect opponents. The ultrasonic sensor works by sending out a high-frequency sound and listening for the echo of the sounds off of other objects. Using this information, the robot spins until it finds an object within the ring by comparing the distance received from the ultrasonic sensor to the diameter of the ring. The robot will then charge an object to try to find it, push it out of the ring, and win. Since our robot's strategy is relatively passive and more defensive, there is no need for complex movements. The code is highly functionalized to allow for easy editing, troubleshooting, and modification. Each function completes one specific task. For example, the function flag flash has one job, which is to move the distraction flags to a new random position every time it is called. Since this is such a simple function, a call to it can be placed often to allow the flags to move frequently.
The team has also created shallow angles and placed wedges at these angles to make sure our robot is undetectable by the opponents.
To make our robot undetectable, we constructed a few experiments. We first programmed our ultrasonic sensor to read out the distance to the object it would identify. We then held various materials in front of the ultrasonic sensor angled at 90 degrees. These materials may include things like poster board or foam or cloth. Some of the materials were undetectable at 90 degrees and some of them were not. We found that an average angle of approximately 60 degrees made all the materials undetectable. We wanted to use this 60-degree angle in our CAD design for the shell of our robot. From there, we decided to use additive manufacturing, so we actually created 2 prototypes out of additive manufacturing. Our first design was slightly larger. We then created a slightly smaller design. We printed our final body using additive manufacturing for our robot. When we began designing the CAD model for our robot, we used a hexagonal base to ensure that we could construct walls precisely at this 60-degree angle while also having a ledge in the front that we could use to push our competitors out of the ring. Our design is slightly smaller than 30 by 30 centimeters, but still has enough room for all of the components inside of our shell.
The final step in our design process was creating the vacuum-formed outer shell. We did this by using the vacuum-formed machine in the Learning Factory.
We thought this was necessary because it would double as a shield that would be the exact shape of our 3D printed model and also add the extra wedge that would lay flat to the floor and deflect opponents as they tried to charge us.
This is also a feature that distinguishes our robot from other robots taking part in the competition.
State College, Pennsylvania, what a nice happy valley. Oh yeah, Penn State University, teaching all the people in State College, Pennsylvania. Oh yeah, what a wonderful area. Oh yeah, a best place in the whole wide world. It's a happy valley. Oh yeah, State College got a lot of nice people. Oh yeah, State College is a quaint and wonderful